Hi, I'm Siddha, and in this video I will explain about how to visualize data in geographical maps of a country or geographical maps of a world. To explain how to visualize the data in STATA, I will take an example from Nepal. So in STATA, the required packages for data visualization in geographical maps are the SP map and SSP to DTA. So you can install these packages by simply typing SSC install the name of the package SP map and by running this command. And the SSP to DTA package is used to convert the save files of country to the STATA files. So you can install these two packages. I have already installed it, so I will not install it again. So the first step in STATA to produce the graphic visualization is setting the working directory, which can be done by the cd command. So I will tell STATA to set the working directory as the desktop map and STATA folder. So I have saved the required files and I want to ask STATA to save all the outputs in this folder. So I copy this command and I tell STATA to set the working directory at the STATA folder. So if I run this command, STATA has set the working directory. So the next and most important step is to download the save files from internet of your country. So in case of Nepal, I just googled the Nepal save files and I found a lot of websites that have the save files of Nepal. And one useful save files for Nepal that I found at the Code for Nepal website, codefornepal.kato.com. So I downloaded the save files from this website, download and SSP option. So it downloads the save files for Nepal. So there are 5 files with distinct extensions. All of these files are not required. 2 of the files that are required for STATA is the .dbf file and .ssp file. If you copy or if you extract and copy the single file only, STATA will not work. So it is better, it is safe to extract all of these files and put them on your working directory. So I have extracted all the files and put them in my working directory. So the next step is to convert the files into the STATA files. So for that, the SSP to DTA command will work. So if you have not installed the SSP to DTA package, this command will not work. So first you have to install this package and then type SSP to DTA using the name of the file, the name of the SSP file, but without any extension. So you should not type here SSP. So simply the name of the files from your working directory. So the name of the file is save file of districts in Nepal. So the name of the file, comma, database, then the name of the database. So this is the name of the file that STATA will create and save information in it. So then the name of the coordinate file, so the name we want to give for the coordinate file is Nepal code. And for differentiating the geographical sub-regions, STATA will create an ID and we name the ID as ID. So you can give any name that will be distinct for each of the districts in our database. So if I run this command, STATA will create two files, one Nepal DB and another Nepal coordinate. So if we go to working directory, STATA has created two STATA data files. One is Nepal DB and Nepal CORD. So we can just look at those files. So first I will use the Nepal DB to look at what is inside it. So I just imported this data, and if I click the browse button, we can see that there are district codes, district names, SAFE area, SAFE length, and other information. This ID variable was the one that we created just before. So we can see that the IDs are distinct numbers for the 75 districts. So I just describe the data set, the name of the variables, then we can see what is inside another file that we have created, Nepal code. If we browse, we can see that it is just the X and Y coordinates, for each of the districts. So these are simply the boundary points. For instance, for the first districts, there are more than 1600 boundary points. So you can just tabulate the ID and see that how many distinct coordinates are for each of the districts. For instance, for the first district, there are 1669 coordinates. So you can just browse and see the coordinates for each of the districts. So there are altogether 55,251 coordinates for all of the districts in this data set. So next I move to work with another data set that I want to visualize. So in this example, I want to visualize the poverty rate by districts in the map. So I now look at the poverty data set. I have already saved the poverty data in the working directory, so I can just import this file and see what is inside it. So if I describe the poverty file, there are only few variables, as you can see. Sorry, I have run all the commands again. So if I just use poverty and then describe, so we can see that it is just three variables. One is ID, another is district name, another is poverty. So I want to visualize poverty. So I should merge this data with the original data set extracted from the SAFE file. So now what I am going to do is to simply merge this file with the database, Nepal database file that we created. So I first use the Nepal database file, and then I merge the poverty file with the Nepal database file. So this is merge one-to-one by district name using poverty. So the Nepal database file is already imported, so then I merge the Nepal database file with the poverty file by using the merge command, merge one-to-one by district name using the poverty file. So after merging, we can see that there are no unmatched observation, and all the observations are matched from the two files. So now we can see that the geographical information system data and the poverty data are in a single STATA file. So now I can plot this data by simply using the spmap command. Spmap, then name of the variable that I want to visualize, then using the coordinate file, and the ID is ID. the distinct number that we created for each of the districts. So if I run this command, the map of Nepal will be created by filling the color of the districts according to the poverty rate. So it has created an index, for instance, the district with poverty rate from 4% to 17%, 4% to 17% are colored with white, and the districts with poverty rate from 35.5% to 64.1% are colored with this dark brown color. So now we can modify this graph. For instance, we can change the color scheme. We can change the color scheme. We can change the number of classes. For instance, if I run this, this changes the color scheme. This changes the legend style. For instance, it puts the color in reds. The column number means the number of categories. The legend style has been changed, and the background color has been changed. So you can even further add some other features by running this command. So here the color scheme, same, column number same. I have added the O color feature as rainbow and O size. So the O color feature separates the boundary of the districts as different colors. The rainbow color means the poorest districts are with red boundary, and the richest districts means the districts with the lowest poverty rates have been drawn with blue boundary. So in this way, you can change the color scheme, you can play with the background, you can play with the legend style, and you can even put the name of the districts and the poverty rate in the map. So to do so, there is a simple trick that while generating the STATA file, you should add another option as GenC inside parentheses C. So this generates the coordinates x and y. This generates the coordinates x and y and put it in the database. For instance, if I run this command, and save the data in Nepal database 1 and the coordinates at Nepal coordinates 1, let us see what is the extra information generated by adding this option GenC equals C. So let us see the Nepal database 1 file. So I import this in STATA memory, and if we look at this file, so the two more columns have been created here. One is the x coordinate and another is y coordinate. So one is x coordinate and another is y coordinate. So if we use the GenC command, it will generate x and y coordinates, and I again merge this data with the poverty data, and I save this data file as the Nepal db2 file, and we will work with this file while visualizing the data. So I use this Nepal database 2 file. So to show the name of the districts and the poverty rates, I have done a simple trick here. So I have generated a variable called db equals 1. So so I use Nepal database 2 file first. If you look at the data, there are 75 observations. So now I will copy all the observation and put under this, and I will generate a variable called db and put 1 for the original values and 2 for the copied values, and I will change the district name here by the I will change the district name here by the rate of poverty. So let me do that first. So the trick is to create a variable named db equals to 1, then append the same file. So let me look at the file. There are 75 observation now. Now I attach all the data below it, all the data from the same file below it. So for that I can just use the append command, append using the Nepal DB tool. So if I run this, now there are 150 observation simply with the same information twice. So let me start from here. Okay, so these are from the original, and I have appended the same data. I have appended the same data here. So I will now change these dots to 2. For that just replace db equals to 2 if db equals to dot, and now I will just replace, now I will just replace the name of the districts by the poverty rates for the next 75 observation that have coded as 2. So for the observation, for the 75 observation, for the first 75 observation, I will keep the name of the districts as it was, and for the next 75 observation that I have just attached, so I will change the name of the districts by the poverty rate. I will replace the name of the districts by the poverty rate. This is just to visualize the name of the districts and poverty rate in the graph at a time. So now I will replace district's name by poverty, but I will convert the poverty figures into string values, and I will replace if db equals to 2, I mean for the next 75 observation that have appended. So I will save this as the lab file in my working directory. So now I again use the Nepal db2 file, and I now plot the map, but at this time I will use the information saved in the lab.dta file. lab.dta file has the label values as the name of the districts and the label values as the poverty rate and that we created and saved before. So now I use the SP map using the same information, but I will use this information here. This information is for labeling the graph. So data is from lab file that we created. X coordinate is x coordinate created by the gencc command, and y coordinated is the y underscore c created from the gencc command, and the label is district name because the district name colon has the name of the district as well as the poverty rate in the lab file. Okay, if I run this, it will plot the map of Nepal but with the label values here. So now here if we look at the map, it has the name of the district as well as the poverty rate in the map. So here I have changed few other things. For instance, so I have changed the plot region color by green, I have changed the graph region color by blue, and I have changed the legend style, and I have changed the color of the title as white. So So you can play with the options here. The basic things is that you should have installed the spmap package, and SSP to DTA package, and you should have downloaded the save file of your country. So thank you for watching this video. I have put the data files and the save files and the command file for our command file for STATA, the STATA do file, in the description of this video. And you can even watch about how to create this plot in R. The link is given in the description. Thank you very much. Keep connected. In the next video, I will explain how can we produce the world map and visualize the COVID data, the COVID-19 data in that map.